Once a night, a speech-impaired mother suddenly felt severe pain. No one understood her, and she got the wrong treatment. It's not a story. Data says speech-impaired mothers have a 3 times higher risk of medical errors due to miscommunication alone. So we developed Arbor, powered by GPT 5.6 and Codex, a communication assistant specifically for speech-impaired mothers. Every maternal emergency assumes the mother can explain what's wrong. But what if she can't? Arbor gives a voice to mothers who cannot communicate by combining wearable sensing with an adaptive AI agent. In our system, edge sensors receive biological signals from the wearable device and send them to the cloud, where GPT 5.6 acts as the agentic reasoning engine. Based on sensor thresholds, GPT 5.6 analyzes the mother's biological signals, patient context, profile, and behavior to understand what she needs. It then determines the most appropriate care pathway, contacting her husband, reaching the right doctor with detailed context, adapting its decisions based on caregiver input, booking a new doctor if needed, and sending all necessary information to the doctor. GPT 5.6 analyzes evidence, explains its reasoning, creates adaptive care plans, understands human instructions, and coordinates doctors, caregivers, and emergency services through intelligent tool orchestration. That's why we built the Judge Dashboard, to let judges see exactly how GPT 5.6 manages the entire process. But what happens if the internet disappears during this journey? Does the system stop? Does everything vanish? Our answer is simple: no. When a vulnerable mother loses internet connectivity, the wearable device continues silently monitoring and recording everything. Nothing is lost. Once the connection is restored, the system synchronizes the data, generates a complete report, and resumes the required actions exactly where it left off. Codex usage. Codex served as our AI engineering partner throughout development, accelerating implementation while we directed the architecture and validated every change through automated testing and iterative engineering reviews. It helped build and refine non-trivial systems, including offline continuity with event synchronization across intermittent connectivity, an agentic reasoning pipeline with adaptive planning and tool orchestration, real-time WebSocket communication, PostgreSQL integration, deployment automation, and large-scale refactoring. This allowed us to spend our limited hackathon time designing the AI workflow, validating system behavior, and improving reliability, resulting in a fully integrated, production-style prototype rather than isolated features. It speaks and acts for the most vulnerable mothers when they need it most.